Hi. During IPR5, the Sheehan STEM team made a lot of exciting progress towards transforming our ideas and loose prototypes into more finalized design ideas that we were able to perform qualification testing on. We'll start with our first subsystem of the sensory suite. We started this module with a single ultrasonic sensor that points downwards and maps the distance to the ground, and as it travels in a straight path, determining where the flattest surface was. And we found that this was really successful in a 1D terrain mapping situation, but in a 2D situation, like the challenge that we face here, we found that since we're dropping an object with width, there's the potential that there are obstacles not directly underneath the ultrasonic beam that it was completely unable to identify, which we hope to correct during this module. And the approach that we took to correct this was by developing this new algorithm. Instead of just having a beam going straight down as it moves, rotating that back and forth on a servo motor so that we could scan the entire 2D plane that the egg drop mechanism could fall on. And this is still in development, but we've had a lot of promising intermediary tests. Some challenges that we faced along the way of developing this system was that a lack of precision in motor mounting and sensor mounting to that motor caused some error that was difficult to correct for. So we're hoping to fix that with some custom brackets to ensure stability in the system. We also had some issues with collecting data, and we're working with methods like convolution and pooling to try and work with the Arduino's limited memory while also maximizing the amount of usable data that we can collect for choosing an optimal drop location.
Hi, my name is Connor Howard, and I'm going to be talking about our Subsystem 2 presentation today. So we started off Subsystem 2 in these past weeks, knowing that we needed to do basically a full redesign. So we ended up with this four-legged design here. All of the legs are elastically controlled, and they all can pivot completely upwards, just like that. And they snap down just like that. And they're all attached to a single axis there, so they all have equal tension. And whenever we fall, all of the forces distributed extremely equally. So to create this design, we just kind of looked around, saw the materials that we had. We found we had lots of VEX style parts, so 832 screws, lock nuts, VEX steel shafts, and so we decided on a press fit design for these legs. Every single part that's attached to the steel shaft itself is press fit on, and then we're just rotating them around 832 screws. And you could see these extremely simple parts here. This is just the part that connects the actual leg to the main body. And then we just have the leg base, which is just a simple rounded edge so that it pivots extremely easily on the ground. And then a little hook to grab that rubber band there. And so through testing, we found a few issues. We had a couple breakages. One, we had a main breakage on the main body here, right here. And then on the CAD, it is right here. And we just fix this extremely easily by just adding a little bit more material there to that bracket. We haven't had any issues since. And then we had another breakage on one of these pivots here. We actually found that was due to layer delamination. So we just changed our 3D printing settings up a bit. We increased the temperature, and we haven't had any issues with those parts since. And then now, so for actual testing, we found the easiest way to do this was a roll of tape, which was the approximate diameter of the hole that we were going to drop this out of. And then if you see here, the legs snap downwards, just like that. And then the craft lands extremely easily. And so obviously you can see that it bounced a little bit there. So through more testing, we found that these thinner rubber bands that seen here worked a lot better, and they minimized the bounce, so we can receive those qualification points. And then now for actually dropping the craft, we're just planning on using a servo horn that holds string attached to these four holes at the top of the craft here, so that we can extremely easily drop it just by pushing a button on the craft. Thanks for listening. This has been Subsystem 2.